everyone. Welcome back to another exciting day in mathematics. Warm-up 105 should come up on your screen as soon as you log in. Shouldn't take you long. By the way, today's session, we are moving on. You do need a calculator. Make sure you have one handy. All right, copy it. All right, here we go. Share with me what you got so that we can get this show on the road. All right. All right, good communication. All right. What'd you get for mu, Carter? $18.6. Thank you. Variance. What'd you get for the variance? Austin. S. 126.3. All right. Standard deviation. Vianney. 11.2. So that takes us to 29.8 or 6.6. Yeah, so the norm is between 6.6 and 29.8. Hands, if you got something like that? Yeah, all right. Are we done? No, pass on one to Vianney for the last portion. Brandon, he's not here. Kieran, what'd you get for the last portion of the measures of variation? Two. Vianney. So measures of variation, we got the variance, we got standard deviation. Which one are we missing? The range, which is 33. All right, send that in, please. Let me send you a screen. All right, and copy the agenda. Warm-up 105 is done. Discrete probability distribution. Today we're moving on to another portion of this discrete probabilities. And tonight's home plate, 2 problems only. Copy that, please. All right, copy the code to access the home plate, QDNTB. QDNTB. All right, QDNTB. Try to go this weekend in the fair. Pretty good, yeah? Some of you went? No? Yes? About the Blue Angels? Did anybody go watch the Blue Angel show? Yeah? All right, good. And we were like, I just slept, Mr. Q. All right, good. All right, so of course you guys have been studying your formulas, yes? Because Friday's coming. Let's go, Cole. Let's go. Tonight's home plate looks something like that. Oh, yes. All right, get a Cornell note going, please. I can define and compute the discrete probability distribution. I can define and compute the discrete probability distribution. Bless you. All right, here we go. So, as I mentioned, we're still in the middle of discrete probability distribution, but by now we are experts at the different types of probability we've been working with already for a while, classical versus empirical and subjective. So if I was to ask Austin T to enlighten us between the difference of classical versus empirical, of course he's going to be very versed with that. And then if he passes that to Carter, he'll tell us what subjective probability is that as well. So we're good with that. From there, we talked about variables. We talked about discrete versus continuous, and we've been working right now with discrete. And we said discrete probability distributions, we basically said it's a table. The probability distributions, we can make a table to find all probabilities, and the probabilities have to equal to what, everyone? 1, that is correct. The different formulas that we've been using is the means, variance, and standard deviation for those. Well, today it brings us to another portion of probability distributions. Writing utensils down, look up to the screen. Check this out. Today we're looking at binomial distribution. And let's find out why they're called binomial distribution. Pay attention. I'm going to read some statements so you can start thinking in your noodle, why are these binomial distributions? It reads, when a coin is tossed, it can land either in heads or tails. When a baby is born, it can either be male or female. In a basketball game, the team either win or loses. When they ask you to answer a true-false question, there's only 2 answers, true or false. A medical treatment can either be classified effective or ineffective. In regards to blood pressure, a person can have either normal or abnormal. For multiple choice questions, even though sometimes you have 4 to 5 different options, at the end it's either what? Correct or incorrect. And once again, why are these called binomial experiments? Think about it. Why are these called binomial experiments? Talk it over to your neighbor. Why do you think those are called binomial experiments? Because at the end, what? So let's see. Let's go with Max. What do you think, Max? And there's no passing this one. This is all you. I read all the statements very, very clear, and you were paying close attention to each statement and not looking at your electronic devices or anything like that. So therefore, this one is a binomial experiment because of what? All of them have what? 2 outcomes. That is correct. That's what makes it a binomial distribution. Max in the house. Let's go. So, for that, we do need a formula. So, copy this formula down, please. Oh, yes, we're getting there. Good thing you guys have been doing all your practice. Copy that formula, please. We'll break it down in a little bit. All right. So there's your formula. Now, by now, we should know what each component is, except for P and Q. I'm going to talk about those too. But the rest, you should. So talk to your neighbor. Let them know what the rest mean. Then we're going to have Austin T get us started. What do the rest of the components mean? Once again, P and Q I'm going to go over. All right. N stands for what, Austin T? The total number of numbers. All right, good. So what does X represent? Pass someone? Close. This is the specific number that they are going to be talking about. A specific number. So, for P, I want you to do that in red, label it in red. This is probability of success. So P is our probability of success. So if that's true, what do you think Q is? Pass someone, Carter. Brandon Darty. if Q is probability of success, what do you think Q stands for? Yes, probability of failure. That is correct. Ooh-wee. Label that, please. And of course, the rest you already know. The X is still the specific number they're talking about. N's are still the total number of numbers. And we know what factorial is. Yes? Yes, Mr. Q? All right. So, let's get on with it. Here we go. Here goes our first problem. Example Q. Copy that one on your notes, please. Let me read it out loud as you copy it, so at least you can have one example of this binomial distribution. And it reads, a survey found that 1 out of 5 Americans say he or she has visited a doctor in any given month. If 10 people are selected at random, find the probability that exactly 3 will have visited a doctor last month. I'll give you some time so you can copy that. Go. All right, here we go. So, since everybody already copied it, in our formula, what are the values that we're going to need? Well, we're going to need an N, Mr. Q. So on the side, I want you to write N in green. We need an X value. Do that in black. We need a P value, which is our success. I'm going to do that in red. And then in blue, a failure value. All right. So now, before I get started with that, let me just elaborate a little bit more on that formula that we just wrote down. So, by now, we should know how to find the total number of numbers from the problem and the specific number that they're talking about. But let me elaborate on probability of success versus probability of failure. So, look up, please, where you have your formula. Make a little note for yourself and write P plus Q should equal to 1. P plus Q should equal to 1. So, if I say the probability of success is 5/6. Don't copy that. Tell your neighbor, what do you think the probability of failure is? Cole, if the probability of success is 5/6, what is the probability of failure? Yeah, that is correct, 1/6. And why is that? Because if you add both of them, that gives us what? 1. Okay. Still another one. Let's see. What if the probability of success was 85%, which is written 0.85? Tell your neighbor the probability of failure. What is the probability of failure? And then Cole's going to pass him one. All right, good conversation. Cole, pass him one. Brandon Doherty. Probability of failure is 15%, or in decimal form it's 0.15, and 0.85 plus 0.15 should equal to 1. Okay. Which brings us to our problem at hand. Here it goes. First, let's read the problem one more time, and it reads, a survey found that 1 out of 5 Americans say he or she has visited the doctor. That's a success. So what would I write for P, everyone? 1/5. That is correct. So if that's my probability of success, what do I write for Q, Austin T? What is Q? Q? Everyone? 4/5. Ah. So, we got that from here. Okay, so we're done with 1 out of 5 and 4 out of 5. Okay. Therefore, if 10 people are selected at random, what is probably exactly 3 having to visit the doctor? All right. So, tell your neighbor which one is N, which one is X. All right. Austin T, which one is N and which one is X? N is 10. And 3. All right. So, now that we have all our values, let's write our formula without any of those values. Any of the values so we can fill those in. So, P parentheses equals blank factorial over times all right, let's start with X. X is 3. X goes right here, 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 and here. All right? And we got 10, 10, and 10. P is 1/5. And Q is 4/5. So, P of 3 equals 10 factorial over 7 factorial, 3 factorial, times 1/5 to the 3rd power is 1 over 125, times 4/5 to the 10 minus 3, that's 7 power. All right. Probability of 3 is 10 factorial is 10 times 9 times 8 times 7 factorial over 7 factorial, and then 3 times 2 times 1 times 1 over 125 times, all right, calculators calculate. Somebody help me, what is 4/5 to the 7th power? So I can have a number for that. All right, so 4/5 to the 7 is approximately 0.20. 0.20 what? 9? All right. So, 7 factorials cancel. We're left with 10 times 9 times 8. That is 720 over 6 times 1, 1/25 times 0.209. P of 3 is 120 times 1 over 125 times 0.209. So calculators calculate. P of 3 is approximately what? All right, Austin Ash, pass someone. Kieran. 120 times 1 over 125 times 0.209 is approximately 0.2. No decimals? All right, we'll leave it at that. All right, send me your notes, please. Oh. Give me a second. There it is. And before we move from 1 to 5, how comfortable are you using those parameters now? You got 4 5s, 4 5s. All right. So example super Q reads, a survey from Teenage Research Unlimited, Northbrook, Illinois, found that 30% of teenagers or teenage consumers receive their spending money from part-time jobs. Okay? If 5 teenagers are selected at random, find the probability that exactly 4 of them will have part-time jobs. All right? So before we do that one, don't copy the problem. I want you to write me on the screen what N is, what X is, what P is in decimal form, and what Q is in decimal form. All right. What you get for N? Pass someone, Brandon. Cole. 5. Oh, that is correct. Pass someone for X. 4. How about success? Probably a success. Pass someone, Logan, for in decimal form. Sam. In decimal. 0.3 or 30. And Q, what'd you get for Q? Austin, T. 0.7, all right. Man, Austin T's on the ball. Let's go. So, apply that to the formula, get me a number, and then we're going to have Austin T walk us through that problem as soon as you guys are done. Copy and all right. Let's see. Austin T. Oh, he went left, stepped out. Have his neighbor help us. Amelia, help us set this up. What's X? 4. So all the X's are 4, 4, 4, 4, and 4. N is 5, 5, 5. P is 0.30, and Q is 0.70. All right, so P of 4 is 5 factorial over 1 factorial times 4 factorial times, what'd you get for 0.30 to the 4th power, Amelia? .0081, okay, times 0.70 to the 1st power, so it stays 0.70. So P to the 4th is 5 times 4 factorial over 4 factorial, which at the end we just have 5 times 0.0081 times 0.70, and that gives us, Amelia, approximately 0.023, you said? .023, 28, like that, 25, 35. Hands if you got something like that. All right, send that in, please. All right. So, from 1 to 5, how comfortable are you with that? All right, 5, 5, 5. All right. So, with that said, your home plate is up on the screen. For number 1, pick either A, B, C, D, or E. And then number 2, answer the question for number 2. All right, those of you following on YouTube, make sure you put in some practice in. See you guys next time. Peace.